All right, welcome everyone to another session of The Talk. You are here with myself, Mr. Scott Lylander, and we have a very special guest tonight to talk to us about power supplies in audio and also about just power in general. We have got Vladimir Kraz from OnFILTER. Vlad, welcome to The Talk. Thank you so much for being here.
Thank you for having me. I'm glad to be here.
This is the talk is an extension of the show, Total HiFi Experience. If you're here, you are on Facebook or YouTube, and I would encourage everyone drop a line. I'll share the content. I'll share you, and we've got a great friend out there, Harris Fogel. How you doing, brother? Thank you for being here. We've got Mr. Larry Stugel. Thank you for being here. And if you're looking for the link, the show, theshownow.com, and on YouTube and Facebook, the show Total HiFi Experience. So, Vlad, amazing to have you here. Welcome to the talk. Why don't you talk about yourself? The first question: are you an audiophile?
I believe the proper way to say it, I am Vladimir Kraz, and yes, I am an audiophile. I believe this is how it goes in Alcoholics Anonymous. Yes, I'm an audiophile. And maybe of slightly different flavor, but yes, I'm an audiophile.
Hey, there are many flavors in this industry, and that's what makes it special. Because I love this industry because you get to meet some of the smartest people around there, and there's lots of different ways to slice the bread and to make a sandwich in this journey. But you're going to share with us about OnFILTER and about what you do and how you started. So why don't I just hand it over to you and ask you to share with us about yourself and OnFILTER.
Sure. So OnFILTER is a 10-year-old company, and we will get close to it. But first, am I really an audiophile? Well, yes. Back in the evil empire, I graduated. My second degree was in audio engineering. So I have an engineering degree in audio from St. Petersburg. So I was born in Ukraine, married my better half in St. Petersburg, used to be Leningrad, came to the US in 1983. Just to give you an idea how long ago it was, we flew in New York on Pan American, and from New York to San Francisco on DC-10. This kind of gives you a little time frame. So I began to work.
And back in the day, you could probably smoke on the airplanes, right?
Well, if I smoked, I probably could. Yes, there was a smoking section. I wouldn't want to sit right behind it or in
Agreed.
front of it. It was interesting times. So I did some work in audio. I was working on communication headsets, which gave me a pretty good foundation in modern audio testing. Then I worked on semiconductor design. I worked in industrial control, many other companies. And in my kind of previous company, we were doing EMI and ESD for electrostatic instrumentation. And I noticed, because I traveled the world, I probably spend at least 10% of time somewhere in Asia, because this was a manufacturing is. Although our products made in the US, but shipped there. And what I've noticed all over the world is that power quality sucks, big time. And if there is one thing common for any electronic equipment, it is power. You can paint it pink, or you can have a cable the size of the hose, but you still need power. And what I noticed that the conventional filters don't really do their job, and some of them actually amplify the signal. It isn't their specification. It was very cute to see. So 2010, I started OnFILTER. Oh, let me take a step back about audiophiles. Back in what used to be the Soviet Union, you cannot really go and buy anything of quality. The
Okay.
consumer product electronics was not really a priority for the state economy. So you had to make it your own. I actually have a Soviet patent for a tone arm, for linear tone arm. And I did a turntable, because the quality of the best turntable at the time was the same if you go to the drugstore to buy a $60 Enterprise. And I did a turntable based on eddy currents on old electric meter, not the smart one, but old-fashioned dumb electric meter where things rotate because of eddy currents. Because my father, shipbuilding engineer, taught me that the most reliable part of any equipment is the one which is not there. It never breaks, it never bothers you. So I decided, okay, how do I remove the belt? How do I remove things that are not essential? Because this way, I don't need to worry about their performance. And I had made a big disc, properly designed, and under it was little, essentially I took apart the electric meter. Don't ask me where I got it. And it worked like a charm. You can control the speed by adjusting the load. It was very, very smooth. It didn't quite have oomph to start, but once you started, it was great. I did my own speakers. Anyway, going back to filters. We began to design, started with AC filters. Filters that clean up AC power. Because what I figured out, that the more we go into the future, if I may, the more noise pollution we will have, electrical noise pollution. Because people think that your power company supplies you with a lot of noise, and it might. But in my experience, again, traveling the world and seeing all the things, measuring things, not just saying, it is what is in your house or what is in your office or what is your factory that causes a problem. LED lights, the replace questionable pollution was actually a measurable one. Solar panels, they have inverters, it produces pollution. Your neighbor, when he installs a solar roof, guess what happened? All the noise comes to you, to his neighbor.
Well, that's really interesting. I always thought that I personally I didn't know that solar panels had a lot of electromagnetic or just line pollution. I want to ask you to explain on that, but I don't want to inhibit where you're going. So please do.
No. Thank you for asking. So the solar panels by themselves, they produce DC voltage, and it's reasonably clean as far as voltage goes. But it needs to be converted to 50 or 60 hertz, wherever you are. And for this, people use inverters. Inverter is, in essence, switch mode power supply. Switch mode power supplies work on pulses. And sometimes pulses themselves is only part of the problem. Is the sharp edges of these pulses are a big problem. And why sharp edges? Because it's cheaper. And the new transistors, so-called wide bandgap transistors, silicon carbide or gallium nitride, they shortened the transition from 0 to whatever level they use down to just about 3 nanoseconds. So now your power line is kind of full of garbage. Then, if you happen to buy, let's say, some appliance, refrigerator, or a washer or a dryer within the last few years, it is highly likely that it has variable frequency drive motor instead of old-fashioned motor. Why? Because, well, it's smaller, it's cheaper, it's easier to control, and it does save electricity a little bit if properly programmed. And guess what? It works on pulses. And pulses are not your friend if you're an audiophile. Then take a walk around your house and count how many switch mode power supplies you have. Your phone charger, everything is plugged into the outlet. And thus you have a whole lot of a Martian band with drummers polluting your electrical power. And it has little to do with your power company. It has to do with you. So this is where the noise sources are. And I saw this thing kind of coming stronger and stronger as far as noise coming. I said, well, I think this problem needs to be solved, or at least addressed in a meaningful way. And I analyzed why conventional filters really don't do their job. If you do your job by the book, you end up with a whole lot of noise. So it's a little bit of interesting development. And our filters excel in actual environment where it matters, means yours. Yes, Scotty, you had a question?
So I do. Thank you very much. I want to go back to a point where I didn't quite catch it, but if you do your filters by the book, then what happens?
Okay, so the filters that are done by the book, they are done for a very specific purpose, to comply with government regulations. How I would say it, whenever you try to comply with government regulations, your real life performance is not really up to par. It's a long story. We're not going to fit it in here, but I have one of my links on a website does explain that. So in essence, if you do it by the book, if you do it in the most classic way, your filter will work under very specific circumstances. It may work very well, but put in real life situation, you might have noise actually being amplified. So we started with AC EMI filters. And we really didn't know who and what would be bind filters. All I knew is that noise is a problem for everyone, or at least for some people, and it will get only worse and worse. And if I were to kind of span the range, it would be anywhere from a farm to quantum computing, to space. Anybody who needs clean power eventually comes to us. We're the last stop after you exhausted all the standard ways. You'll come to us and we'll give you nice clean power. And truly, there is no limit to applications. Yes.
So you started OnFILTER by understanding the lack of design efficiencies in the government standards and the realization that industry, not just the audio industry, but industry in general, needs really clean power. And that's how OnFILTER started, correct?
This is a good summary. Yeah, this is a good summary. And you can find our filters in many different ways without even realizing. For example, if you go to a supermarket, you go through the freezer section, and there's a good chance our filter is looking at you from there. Any robotic equipment, we have special filters for servo motors and variable frequency drives that make it nice and quiet and improves accuracy. I'm sorry, let me shut the phone down. We have ground filters because ground is like a sewage. Everything goes into it. And just imagine that you have, let's say, a big apartment house or hotel, and if you flush some garbage down the drain, guess where it goes? So all our AC filters clean not only power but also ground, and we have a patent on it which makes it safety compliant. We have filters for data, for example, at the factory, when I need to communicate with sensors, we have filters that help you to do that. We have filters for DC, we have measurement equipment. It kind of grows one step at a time, and our customers could be small users, like audiophile is a small user, or could be a big factory somewhere in Asia, in China, that will buy hundreds and hundreds of filters. So this essentially is what we do. We make our filters all in the United States and export all over the world. I would say proudly that to all 7 continents, including Antarctica. It was fun to ship in there. It's less than conventional way to get your goods from California to Antarctica.
Less than conventional. So I want to I want to share an image file right now because we're talking about the show. So we've got back in June 2025 and Costa Mesa, we've got the show here, and I actually I realized you were beside Tiki Tube amps, but you've got a filter here on the screen.
Yeah.
Can you tell us a
Sure.
little bit about this?
Okay, sure. So engineering Bible starts with, in the beginning there was a specification, and it goes from there.
Love it.
Specification from technical point of view, it means that we need to achieve a very specific goal. We can exceed it as long as it doesn't damage anything else. And from overall business side, it's our promise to the customers, saying we provide you with a product which is good, and this is what it measures. Because if I just say the product is good, it sounds terrific and this and that, to me it means exactly nothing, shaking of air. If you want, in case of filter, great. I need to provide you with exact performance. If I supply noise at any particular frequency, how much attenuation I get. Because if I don't have such specification, I mean, nobody in a business, nobody at a factory or an R&D center would even consider buying a product without hard specification.
That's right.
And so what you see here is all the on yellowish, greenish here kind of trace is this nasty stuff that was present at in the outlet of the show floor, and this could be relatively mild. Go ahead.
So all of the I see a very complex waveform there. I see a lot of peaks. I see a very high crest factor, but all of that is coming from the noise on the power inlet before the filter, right? And that's all the switch mode power supplies that are plugged in. It's all of the pollution that's coming into the line. And, in my house, in your house, we're getting similar types of, signals like that.
Oh, yes. So this, what you see is kind of aggregate. For those who never saw oscilloscope on horizontal axis, it is time, and all the squiggles. What happened with time? And in every place there are some strong. For example, in a hotel, you'll have your lights, you have your HVAC, you have a whole lot of appliances, you have vacuum cleaners, you have a lot of stuff.
Refrigerators.
Oh yes, in my home, I have one particular very unimportant little light that produces so much noise, totally disproportional to the light it produces.
Wow. So I just want to, while Vlad is having a sip there, I'm here. Cheers. I got a Pellegrino water. I just want to say that if you have a fluorescent floor lamp in your audio room, that thing has got an inverter and is probably creating noise into your power system.
Okay, so fluorescent light does not have an inverter, but it has a different type of circuit. And yes, it creates a lot of noise. Why would you want to have fluorescent light when you spend so much time on your studio?
Get rid of that.
You need to have good old-fashioned incandescent light. By the way, on this screen, you see this greenish-yellow thing. So the question is, what is this blue line on the bottom? And this is the same signal after our filter. And if you kind of squint, you will see that the amplitude of upper signal was close to 0.5 volt. And on the bottom, it's a meager 20 millivolts. So this is what our filters do. If you look at our specifications, this is what our filters do.
Now,
go ahead.
What about the mains, right? The 120 volt, 60 hertz, power that we plug into our amplifiers, and then our amplifiers use that. Where's that on the screen? I just have to. Is it biased out or?
Okay, so what this picture does not show the rest of the table. One of these pictures you have on the table, maybe one of the previous. No.
Okay,
anyway, it's okay. It's okay. No worry. We have our instrumentation. It's kind of in the left corner beyond the frame. That actually used by a lot of companies, and used even by NIST, National Institute of Standards and Technology. It's like saying that the Pope uses your rosary. This is the type of thing.
Absolutely.
Yes. Our instrumentation go to our website to go to measurements, or TNM, test measurements. They completely block 50 or 60 hertz. And what you see is only EMI. Because we don't do anything with the 50 or 60 hertz at all. This is between you and the power company. We don't limit the current. We don't do anything at all. We simply kill EMI, and we're pretty good at that.
So then if you say that you don't limit the current, does that imply there's no transformers in the filter?
No. Transformers, anything you put between the input and output may affect the quality of power. And transformers, no, we don't need it. More than that, we have some tests done by professionals that show that our filters reduce common mode noise way better than a transformer would. I'm not saying that a transformer-based product is inherently bad. What I'm saying is that we don't need it to produce essentially very, very clean power.
Very, very interesting. Now, there's some claims out there that some power supply conditioners, and I'm not an expert in this. This is a question. They say that they remove the DC voltage.
Okay.
Can we go there?
Sure. So we began to sell products to audiophiles by sheer accident. A couple of years ago, people began to buy it. And first we considered as a curiosity, sure. And then more and more people began to buy it and said, okay, now I need to remember my audio degree. And it was actually fun. But what I realized is that audiophile market works on gossips, rumors, and superstition.
Gossips, rumors, and superstition.
it's very seldom works on facts. So let's talk about DC. Power companies obliged, in order for power utility to deliver power to you, they have to comply with a lot of stuff, and good portion of it is technical specification, and portion of technical specification is no DC, because the power you get is in your house is from the transformer somewhere on the corner. It's kind of an imaginary ubiquitous green box that you normally don't pay attention until it begins to hum. Transformers do not produce DC voltage. They cannot transfer DC voltage by very definition.
So that's the big green box that you sort of see in your subdivision. There might be one for every section, like outside. Someone's house has got the big green box on their lawn, and that is converting, that's transforming the line level power to, distribution level power.
That's right. So when I first got questions, do we have a DC blocker? I said, well, that's interesting. If there is a DC, sure, we can put a DC blocker, but first see if we're actually solving the problems that exist. So somewhere, Scotty, you have two pictures on a blue background with a multimeter. Could you get them?
Yes,
please?
I can. I will absolutely do that.
I do measurement because it's one thing to listen to somebody, which is great. Another thing is to measure. I like to measure because engineers. Yeah, thank you. And there is another one. This one.
I will let me pull that up, and then we'll come
so
back
we'll
here.
alternate between these two. So engineers work based on facts, not on base of beliefs and faith. Engineering is not faith-based institution. That's why you don't see politicians who are used to being engineers. Engineers are very factual people. If I'm proven wrong with irrefutable facts, sure, I'll change my opinion. But here is what it is. So I took a run-of-the-mill multimeter. Well, this is actually a pretty good one. Plugged into power strip, and here it is. This is what voltage in my office. Now switch to another one.
I will do that right there.
And this is exactly the same thing, but I switched meter from AC to DC. And what we see is that on power line, we have exactly 1 millivolt of noise, of 1 millivolt of DC voltage, which is
negligible.
1,000 of a volt. I'm sorry. I don't think people, I don't think I should charge people exorbitant amount of money to cancel 1 millivolt of signal. And this is probably error of measurement anyway. And the thing is that this test is highly affordable. This a multimeter is $10 affair from Harbor Freight and from Amazon. Try it. If there is a DC voltage, sure, then you may want to employ DC blocker. But normally it will be nothing. And if voltage begin to kind of jump up down on your meter, which it might, it's a variation of AC voltage. It's your 120 volts jump up and down. So it's all a matter of measurements. And this is the easiest one to measure. It's another thing people say, well, the high is not as bright, the lows are not that boomy, it's highly subjective. This has absolutely zero subjectivity. Simply measure.
So really, all we're really worried about on the quality of our power is the dynamic noise in our signal, which you've shown here in the green.
Yeah.
Yeah.
Yeah, your power, the voltage needs to be reasonably stable, even though a good audio gear will have reasonable power supply.
Oh, hey, that's a great lead into a question that my friend Mr. Harris Fogel asked, is that, look, if I'm buying a $5,000 or a $10,000 power amplifier, doesn't it already have like like you would think the power supply of that component is well thought out, and does additional filtering add benefit? Isn't it not already there?
Okay, so first let's start from the end. I don't look at it as additive, adding benefit. I look at the subtraction. Would the noise subtract from your audio quality? Our
Absolutely.
filters make sure that it doesn't, because there will be no noise. As far as power supply, I am absolutely positive that good, solid manufacturers would put reasonable filtering in it. Somebody on a budget side may skip on it, or sometimes a designer would pay great attention to the quality of amplification, and power supply would be kind of an afterthought. Also, they would measure it according to the government regulations, which are not only old but have absolutely no basis in reality. So just like I told you before, that you put just normal filters that you buy from catalog, and it may amplify your sound. So one would hope that your sound will be good without noise. But if you want to avoid any surprises, well, clean power never hurt anyone.
Absolutely. And that's why, that's why you see all of these various solutions out there at various price points. I've even actually, like, I'm a audiophile YouTube watcher. I've actually even seen people will hook up their audio gear to like a DC battery and just kind of, skip that whole step.
Okay, let's put on hold on that. A lot of things sound good in theory, and then there's a pesky subject of practicality. So how do you get from your battery to a good, nice, clean 60 hertz sine wave? You need to uprev it. And here we come to the same thing as solar panels, which is switch mode power supply. And again, in Munich show, I saw a huge box.
I think I know the manufacturer you're talking about. I'm not sure if I should call them out.
Okay. But it costs more than my Tesla. It doesn't have wheels. So it's not a winning proposition. And I'm sure they did a stellar job on cleaning the power after inverter. But one says that people go to this length, but this by itself could assure you of a stable voltage, which is a good thing, of stable frequency, which is a good thing, even though your power company must comply with a certain standards. But
now
yeah. Go ahead.
Oh, I could think of one application where a battery might be advantageous. Is that
Sure.
perhaps your DAC, your digital analog converter, it might be a 12-volt DC or a 5-volt DC input. In that scenario, having a dedicated battery that runs to that DC really driven component, then you would just be getting straight DC noise with no noise on it.
Yeah. So I know some of our customers, especially in Asia, where power quality truly sucks. That means business is good. They use essentially if they charge the battery at night and listen from the battery during the day, because nobody really cares about power quality, especially people who provide power. So this could be a good thing. Again, this by itself does not really guarantee that you don't have noise and power. It may guarantee that you have nice clean sine wave, but again, it is. This is one of the things that highly objective. You don't need to listen to anybody's opinion, or you simply can measure it, and it's very inexpensive to do so.
But the people that have been using your power supplies, which you said were never intended for audio. They've been coming back and
Yeah.
saying that, hey, these are working great, and you need to start sort of sharing what you've done in the industry with other audiophiles for them to try it, because other people have heard the difference.
Yeah. So again, we do not claim any improvement or changes in sound quality, because honestly, your power is not the place to do so. So you have so many other things, such as your room acoustic, which is probably, after the Q-tip, is the most important thing for audio. Your room.
Yeah, you definitely need to get the you need to get the band pass filters out of your direct measuring ear canal.
Yeah, you may even have a golden Q-tip award for something.
Now, okay, I want to, while we're laughing, could you share with us? First of all, I want to say, I know that you said you're from the Ukraine, and I want to say,
Yeah.
God bless the Ukraine.
Thank you.
On another topic, I know that you studied in St. Petersburg. Could you tell us a good Russian joke while we're here and laughing together?
I believe you told me in the beginning this was a family show.
It is a family show. We are on the public airwaves.
So let's leave it at that.
Okay. All right. Thank you. So I want to encourage all of our viewers here, whether you're watching live or after, make sure to find out next time you see Vladimir Kraz, definitely ask him for a good Russian joke. And I'm sure he's got a few up his sleeve. But we have another question from the audience here.
Sure.
I'm going to bring it up. And it's Harris. Hey, buddy, how you doing? He says, please ask about the importance of having only audio components on the output of the filter.
I think I know what Harry's talking about. More specifically, if you connected the output of the filter, or we have power distribution unit, which has 6 outlets, what happens if you have, let's say, several things, you have it right here on the right. If you have several loads connected to it, and one of them is not really an audiophile equipment, would it screw things up? The short answer is yes, it might. First, kind of boundary condition. We need to assume that an audiophile equipment does not produce noise back into power line. It's a huge assumption, but that's what it is. Some digital equipment, your streamer, your storage, disk drive storage, or anything of the sort, all your Wi-Fi equipment, can and will produce noise at the output. And after the filter, it's kind of Wild West. Just imagine that this is like a security guard on entrance to some important building. Once you passed it, you can wreak whatever havoc you want. So once you pass the filter, and if you have any noise generated after that, there is no real protection. So if you have any equipment that creates noise, and I really don't care whether it's labeled audiophile or not, it's a matter of measurement. It has nothing to do with subjectivity. Simply measure it. And if it does produce a squeak, put it before the filter, and you'll be good. In most ideal situation, my recommendation is to put your audio your good gear after the filter. For many reasons, but one of them is our filters and PDUs provide clean ground. And if you have some gear connected before the filter, then in essence, you're bypassing the ground filtering, negating a critical improvement in your power quality. So I hope I answered Harry's question.
I think so, and one of those devices that the audience might have in their system that they might not know about is a little LED strip on the back of your audio rack that lights up your gear because
Oh,
you got
yes.
it on Amazon, and it's got a switch mode power supply, and you've got this beautiful, filter cleaning it up, but then you've got a noise generating device
Yeah.
on the output of that, and it's reintroducing noise. So definitely, I think what Vlad is saying is remove the noise from your circuit. I think ideally it would be best to have a dedicated circuit back to a breaker.
Uh, this is not a bad idea. Keep in mind, this is long wires do tend to collect garbage because even if it's dedicated circuit, it goes into pipe along with other wires, and by inductive and capacitive coupling, it'll pick up some garbage. So LED lights,
Uh-huh.
all LED lights have switch mode power supply. So if you have this little bar, well, first keep it kind of away from your turntable because this is your most sensitive piece of machinery there, and plug LED right before the filter, not after the filter, and you'll be good.
Now, is there such a thing as an audiophile grade switch mode power supply?
Define audiophile grade. Means expensive? What does it mean?
I'm not sure. Look, I know of a brand, and I know that they claim to make very high quality switch mode power supplies.
Listen, Scotty, claims are nice, but the first thing I look for is specification. What does it mean? What kind of noise is there? And again, it's all measurable. And specifications, your manufacturer promise to deliver at least some minimum quality. If it says just as good and it's painted pink and wire is that thick, I mean, to me, it means exactly nothing. What kind of noise does it produce? And this will define
Okay.
it.
Yeah. So is it always advantageous to have a linear mode power supply?
No, you can have a good switch mode power supply with filtering. It just depends how well you do it.
Okay. And maybe that's what this brand, I'm not going to call them out, but maybe that's what this brand is intending on in their switch mode power supply, is that they have filtering downstream of that to get rid of noise. Maybe that's what's meant by audiophile quality, is that
Okay.
it's not introducing as much garbage into your signal as,
Yeah.
you know,
Yeah.
a generic switch mode supply.
Well, I hope so. I hope that any audiophile equipment has no noise.
Now we talked about common ground
Yes,
2 or 3 minutes ago.
sure.
I also know that there's I'm pretty sure you're aware of this. Back in sort of Jensen days, they released a paper on the pin one problem in balanced circuits, and how each sort of separate component could have a, a, a difference in what the ground level is, and there is a difference, and then you get a current which is
Mhm.
created. A differential voltage will create
Yeah.
a current flow. Um, I haven't measured that in my system. I just know that some audiophiles will measure the pin one, and they'll measure the ground on their instrumentation themselves.
Okay. Okay. So what you're talking about is called leakage current. Leakage current is how much of your 60 hertz current is goes to ground. So some current goes to the ground wire, and ground wire, just like any ground wire, any wire, is not a superconductor. So it creates voltage drop on this wire. Not much, but you really don't need that much for your ground to kind of bounce around. And since everything is reference to ground, data and sound, everything in reference to ground, then you have audible artifacts. And normally the leakage current is highly regulated. For example, if you go, could you switch back to a picture with a filter so I can show you something? Yeah, okay. So maybe there is another one that shows outlet a little bit better. Yep, thank you. So you see this little green dot on the outlet.
Yes, I do.
Okay, so this means this is a medical grade, hospital grade outlet. But it also means that the filter is hospital grade. There's last letter M. And so a good question would be, why on earth did they bring the hospital grade filter to audio show? It has nothing to do with the age of average audio file. Leakage current for hospitals and for residential environment is the same, no more than 0.5 milliamps. So we decided, instead of having separate residential grade and separate hospital grade, we'll just have just one unit. And what I like about this outlets, because unlike anything else, they don't say, well, this is rhodium, this is gold plated, this is something else. These outlets actually have hard specification on contact resistance, on pull, on twist, on everything. And just in our filter, for example, we use a heavy duty industrial grade outlets. Just imagine some guy with an electric saw or a drill somewhere on a construction site. He cannot afford to have flimsy power or something like this. So we use this type of outlets that have specification and prove themselves with time. So this is what a green dot is all about. And so the leakage current is very important, because if a leakage current is more than a certain amount, it does not pass the safety test. And my safety, electrical safety is something that people may not appreciate who don't deal with electricity. My grandpa was a shipyard electrician. And when I was a little shrimp, I raided his chest with tools, and my favorite was asbestos cord. You can do so much with this thing. And he measured voltage by putting it in the outlet, and he will tell you it's 220 or 120. This is great to have such.
But the level of the shock.
Yeah, I tell you, Grandpa was a delight.
Ladies and gentlemen, do not try that at home.
No, not if you want to watch another podcast. No.
Okay. Now,
yeah, go ahead.
Would the industrial grade plug have better mechanical coupling to the male and the female, being that the tighter you have a mechanical connection, the less you're going to get like vibration and any sort of gaps between the conductive materials?
Yes, this is where the specification comes in. Of course, well, first, I would just wonder why a listening room have a lot of vibrations, but this is a different story. No, the industrial grade and hospital grade outlets have hard specification on resistance, shock vibration, pull strengths, and everything else. Absolutely.
And the leakage current is. I gotta ask you again. My mind was turning. How does the medical grade hospital equipment improve the leakage current? Because I know that you said the standard's the same, 5 milliamps.
0.5. Well, it's 0.5. So outlet itself does not do anything with leakage current at all. It's just hospital outlets have very specific additional requirements as far as contacts, pull and bend and tangential force. And listen, if it's good for intensive care unit, I tell you, it's quite good for your listening room, because this is something. Look up Leviton published. We use Leviton outlets. If other outlets, Hubble just as good. We just use Leviton. They published interesting upnote. Ping mail, send it to you on hospital outlets. What does it mean to have a hospital grade outlet? So again, there's a green dot there. The outlet by itself doesn't do anything to leakage current. It's internal circuit. The
Just
thing is,
improved mechanical contact coupling.
it signifies that the outlet and the product to which it attached is certified for hospital environment. And yes, our filters are used in such environment as well.
Wonderful.
I'll be hard pressed to name an industry where our filters are not used.
Well, I know back, if we take a look here, a list of your filtering companies include Ford and NASA. So, if NASA's using it, there's got to be, it's very important. And I know, when I use measurement equipment, you think about what's the dynamic range of the equipment, and if your noise into your measuring equipment is measurable, then you're reducing the effective dynamic range of that measurement equipment.
Yes. So the most challenging application so far for noise that we heard is quantum computing. They deal with the noise that if you don't believe in it, it doesn't exist. So we supply it to quantum computing in Asia, in US, and into Europe.
Wonderful. Well, I want to be cognizant of the time tonight. First of all, I want to thank you for sharing about OnFILTER. You can go to onfilter.com to check out a lot of applications and the audio products, and you can order a filter for your own audio system there, correct?
Absolutely. We don't have yet ordering system online. I mean, you can download order form and do it. Yes, because one of the challenges for us for AC filters is the world is yet to agree on a common outlet. So if you think of world peace, let's try to practice on outlet and see how that goes.
Absolutely.
So in essence, if you order, you want to go get it right away. But sometimes we build it to order, because you want to ship it to India, to South Africa, you want to ship it to China, or to Europe, or to UK. It's all different.
Well, hey, I want to ask anyone in the audience if they have one last question for Vlad. I want to thank again. I've already thanked you for your time. This has been wonderful. I'm an audiophile because I meet other audiophiles and we just get to geek out. I think, this is the best community. Not everyone's amazing. There are exceptions to the rule, but a lot of the people in the audio world are just, there's just such a wealth of knowledge here. And I've really enjoyed this opportunity to chat with yourself. But I want to ask if there's anything you would like to share before the end of the talk.
Okay. Yes. So here's the thing with audiophile market. People who true audiophile then spend a lot of money on their equipment. That means they made a lot of right decisions in their business and their work. But sometimes when it comes to audio products, they kind of lose it. They hear kind of rumors and gossips. My suggestion is whatever got you there, whatever right decisions you make the same right decision with your audio, and you'll be good.
Wonderful. Now, I know that my understanding is that you have two products. You have a 2 filter, a 2 outlet filter, and a 6 outlet power supply unit, correct?
We have tons of products, but audiophiles seem to buy just these two.
What do these retail for?
The small one on the left for $600, and the one on the right is for $1,000.
Okay, now I think you can buy a connector for a power cable that would exceed the value of what these online filters are going for. So definitely, I think you got to get them. You got to try for yourself. Vlad is making no claims, but he's selling these. He's in the business. He understands the importance of clean audio in the chain. And, the proof is in the pudding. And these people, these other audio listeners have been requesting power supplies from the master. They've been putting them in their system, and they've been saying, hey, you need to share this with the audio community. And that's what you did here in Costa Mesa, June 2025. And that was as an ambassador for the show, I want to thank you for doing that, and just for this time. So on that note, and any departing adieus?
Well, Scotty, thank you very much for having me. I hope I didn't offend anyone, but engineers have to be factual.
Dilbert. Absolutely. Well, hey, on that note, I can't wait to see you at the show New York, right? The international show in New York in October. It's going to be so much fun. And I'm all about. I love shows. I love going and listening and meeting people and hanging out with my friends and making new friends like this. So we'll see you in October at the show. And once again, thank you, Vladimir, for this time, and enjoy the music.
Okay. Thank you. Thank you, guys.